tutorial, we have seen the off subtractor. Following up, now we are seeing the full subtractor. So, full subtractor and off subtractor, there is a one difference. So, in the full subtractor, same like the full adder, what we are taking? We are taking the carry. So, here we are taking the borrow. Okay. Now, it is a digital circuit performs subtraction of three single bits. It contains three inputs A, B, B in, and produces two outputs D and B out. Okay, digital circuit. Okay, performs subtraction of three single bits. Okay, it contains three inputs A, B, and B in. B in is nothing but borrow from previous borrow in. Okay, A is a minuend and B is a subtrahend. Okay, D is difference, B out is borrow. Okay, with this, let us see the basic diagram, which is the three inputs, and this is a full subtracted digital circuit, and output as difference and borrow. And this is the B in nothing but a borrow input. Okay, now let us make the possibility truth table and a K map with this. Okay, now these are the possibilities. Now in the previous video, I have explained you how the difference and borrow will be. Now all zeros, there is a no difference, there is a no borrow. Okay, now 0 0 1, which is like 0 0 1, right? So 0 0, there is a no difference, no borrow, we need to take. Now 0 and 1, we need to take borrow. So borrow as 1, and the difference is also 1. Okay, I hope you got the idea on this. So let us erase this thing. So what is the output for this? Like 1 and 1. 1 0 0. Okay, sorry, 0 1 0, right? So here we need to take borrow as 1, and the difference is 1. I hope you got the idea. Here up to here the difference is 1. Like borrow is 1, difference is 1. Now 1 minus 0, which is like 1. Okay, difference is 1, borrow is 1. Similarly 0 1 1. Let us erase this thing. Anything like 0 1 1, right? So here you need to understand the logic. 0 and 1 means here borrow is 1. Difference d dash is 0 0 minus 1, which is like 1. Now difference minus like d dash minus 1, like 1 minus 1, which is like 0. Final difference is 0. Final difference is 0 and borrow is 1. Okay. Now 1 triple 0 means, sorry, 1 double 0 means 1 and 0, you will get the 1. Again 1 and 0, you will get the 1 only. Difference is 1 and there is a no borrow. 1 0 1, 1 0 1, right? So 1 and 0, which is like a 1. Okay. The difference is 1. Again 1 minus 1, which is like 0. So final difference is 0. There is a no borrow. Okay, 0 and 0. Okay, I hope you got the idea on this thing. So I will also explain this two possibility also. 1 minus 1 1 0, right? Like the difference is 1 minus 1, which is 0. Okay, and 0 minus 0, which is 0. All zeros. Okay, not triple 1. 1 minus 1 is 0. 0 minus 1, we will get the borrow as 1 and difference as 1, like 1 and 1. Okay, I hope you got the idea on the truth table and the uh, difference, how the difference will be, how we need to make difference and how we need to make the borrow with the regarding inputs. Okay, now let us form the K map. If we form the K map, all same K map, if we get like this means it is like the XORs. Now for the borrow, let us make. So for the borrow means 0, 1, 2, 3, 4. The identification to draw the K map. Okay. For I am putting like this means see here I kept inside also like 0, 1, 2, 3, 4, 5, 6, 7. Now apply the 1 wherever we have 1. At the ones place we have 1. So if we arrange so we will get like this. So if we draw the logic means we will get the Boolean expression in this format. Now with the help of these things, let us make the circuit diagram. So why we are taking all those things means we are trying to make the circuit diagram only. Okay. Now let us make the it is the XOR. So we got the difference also. I hope you got with the difference. In the previous many videos onwards, I am explaining about this XOR, like how the logic we got from the off adder onwards. We are getting the same logic, so that's why I'm moving fast forward. Okay, so this is a sequence video. I'm get. I hope you're getting people now. What is a borrow? So borrow is let us write the same thing over here. A bar B plus A bar B in. So this is also all is a normal B. BI means like borrow in. Now if we draw this, first let us arrange with the A bar B. So A bar B. So this is a not get right. So A bar B we have taken with the hand only. Now A bar and B in. A bar and B in. Sorry, this is a bar and B in. This is a bar B and this is the a B bar B in. So all this if we combine with the OR gate, we will get the bar out. So this is how the circuit